Welcome to my YouTube channel. Let's start. Which of the following is not a fundamental quantity in the SI system? Which of the following is not a fundamental quantity in the SI system? So in the SI system, mass, length, time, current, luminous intensity, candela, these all are fundamental units. Mole, that is amount of substance. The SI system. So derived quantity means they are asking which of the from the following, which are the derived quantity. Velocity is derived quantity. Since length is your fundamental unit, mass is your fundamental unit, time is your fundamental unit, and velocity is derived quantity. It's derived. So answer to this question is option D. Let's move to the next question. The dimensional formula of forces. So let's write the formula first. Force is equal to mass into acceleration. So for mass we denote by L, and acceleration is velocity over time. And we know the dimension of velocity is LT raised to minus 1, and time, the dimension of time is T. So when this goes up, so this becomes MLT raised to minus 1 minus 1. So the final answer is the dimensional formula for force is MLT raised to minus 2. MLT raised to minus 2. So this is the answer to this question is option A. Let's move on to the next question. Which of the following pairs have the same dimensions? So let's write the dimension of each and everything: work, energy, power, force, and impulse. Impulse is denoted by J, not I. Work done is force into displacement. Just now we derived the quantity for the dimension of force, MLT raised to minus 2, into displacement is length. So the dimension of work is ML square T raised to minus 2. And energy and work have same dimensions. So energy will also have the same dimension as work done. And power is work per unit time. Power also we derived in the last question. So it is ML square T raised to minus 3. Since the time the denominator will go up, then force already be calculated. Impulse is change in momentum. So it is basically m into v. So m velocity is lt raised to minus 2, sorry, minus 1. So we have been asked which of the following pairs have the same dimensions: work and power, no; force and pressure, no; energy and work, yes; impulse and power, no, not at all. We can compare it. This is impulse. Impulse is change in momentum. Okay, let's move on to the next question. The answer to this question is option C. If velocity, acceleration, and time are chosen as fundamental quantities, what is the dimension of mass? So this we have to solve via the homogeneity of dimensions. So here you have been asked for mass, m raised to 1, and here you have been asked to v raised to x, a raised to y, and t raised to z. So write the dimension individually. For velocity is lt raised to minus 1 raised to x. Acceleration is lt raised to minus 2 raised to y, and t is t. L raised to x, here L raised to y, t raised to minus x, from here t raised to minus 2y, and from here t raised to z, and this is m raised to 0. So mass, there is no mass term in the right hand side. So Yeah, sorry. This is not 0, this is 1. Okay. So what can be the scenario? There is no L, so x plus y of the right side, here it is 0, t raised to 0. So x plus y is equal to 0. That is x is equal to minus y, you can say. Then t minus x minus 2y plus z is equal to 0. Since x is equal to minus y, I can write plus y minus 2y plus z equal to 0. So minus y plus z equal to 0. So y is equal to z. We can write this. Y is equal to z. Right? So we can write, see, x is equal to minus y and y is equal to z. So we can write x is equal to minus z too. Substitute this and get the answer. X is equal to minus y. See, minus x minus 2y is equal to minus z. X is minus z, so that is z is equal to minus 2y minus z. So 2x 2z equal to 2y. Yeah, y is equal to z, right? Y is equal to z. So in which option y and z is same? Not this one. This one is okay. This is not good. And x and z are like in minus 1. So this cannot be their answer. Sorry. Here t is minus 1. That is z is minus 1. If t is minus z, then we find relation between x and z. Minus x minus 2 into minus x is equal to minus z. X is equal to minus z, and it cannot be 2 times. So this is your answer. See, check. LT raised to minus 1, LT raised to minus 2, and t. What is the dimension of mass has been asked. Let's do this again. Or you can do it option wise also. Uh, See, the first option can't be your answer because it will not give you the dimension of mass. Let's solve the other question. Which quantity has the same dimension as impulse? Impulse just now we saw m into v. So m lt raised to minus 1. This dimension is of momentum. So answer to this question is A. The unit of pressure in SI system is pressure. Pressure is Pascal. All you can say Newton per meter square. Since pressure is force per unit area. Newton meter square. Newton per meter square. Or we can write Pascal. A. You have to remember this. Newton is work. No, Newton is for force. Joule is for work. Watt is for power. Dimensional formula of Planck's constant. Planck's constant comes in energy is equal to h nu. So h is Planck's constant. So h will be equal to energy upon frequency. Energy is ml square t raised to minus 2 and frequency is time raised to minus 1. When this goes up, that becomes minus 2 plus 1 minus 1 ml square t raised to minus 1. So answer to this question is option B. The physical quantity which has dimensions m, l raised to 0, t raised to minus 2. This is same as mt raised to minus 2. Let's see. Pressure is force per unit area. So that becomes mlt raised to minus 2 into L raised to minus 2, which is equal to ml minus 1 T raised to minus 2. This can't be your answer. Tension. Tension is force. It's a force. Force is dimension ml T raised to minus 2. So this cannot be your answer. Strain. Strain is change in length over length. So this is dimensionless basically. So this cannot be your answer. Stress is force. Stress is force per unit area. ml raised to minus 2. Stress. Same as pressure. I guess there is no option appropriate here, but I have explained you all the four options. Correct. Which of the following has different dimensions than the rest? Energy as ml square t raised to minus 2. Torque is r cross f, which will give ml square t raised to minus 2. Work done is also has the same dimension. Power has the dimension ml square t raised to minus 3. This is different. So answer to this question is option D. Which of the following has same dimension as strain? Strain can be of three types. If change in length, this is also dimensionless. Change in area over area, so also dimensionless. Change in volume over volume. You can say this is longitudinal. Sorry, it says lengthwise change, areal change, and volumetric change. So these all four are, so all three are dimensionless. So we have to find a quantity which is dimensionless. Refractive index is mu, which is which has no dimension. Refractive index mu, because it is a ratio of two speeds. It's speed in air and divided by speed in medium. So this is dimensionless. Dimensionless. Sorry, just dimensionless. Angular displacement is also dimensionless. Relative density that again becomes dimensionless. In relative terms, both quantities, same quantities are divided. So all of the above, all have no dimensions. Answer to this question is answer D. Option D. Dimensional formula of universal gravitational constant G is. So gravitational force is given by G m1 m2 upon r square, distance square. So the formula becomes F into r square divided by masses. The dimension of force is mlt raised to minus 2. The dimension of length is L square. So L and the R square is L square. M1, M2, so it is M square. Then cut one mass, it will go up m raised to minus 1 L cube T raised to minus 2. This should be your answer. T raised to minus 2, 2 raised to minus 2 L cube. So answer A, option A should be the answer. Which one is not a correct combination of fundamental units? Joule. Joule is force into displacement, that is kg. ml force, mass into acceleration, kg meter per second square into length. So this is correct. Kg meter square second square raised to minus 2. Watt, watt is power. Power is this divided by time. So it becomes kg meter square second raised to minus 3. So it is right. It's not a correct combination. Pressure. Pressure is force per unit area. Force, we have known that mass into acceleration divided by area. So it should be kg per meter per second square. It is right. Momentum mv mlt raised to minus. Sorry, don't write the dimension here. Directly you can write the units. Kg meter per second. It is wrong. So answer to this question is option D. Dimensional formula of impulse is same as momentum. It is changing momentum, and you can write mv minus mu. Both have the same dimension as impulse because impulse is change in momentum. No force, no energy, no. Answer to this question is option A. You can stick to the question and you can solve it if I am going quick. Which one of the following sets cannot be used to define other physical quantities? MLT, yes. Which one of the following sets cannot be used to define other physical quantities? Mass, velocity, time. See, mass, length, time are fundamental units. Velocity is not a fundamental unit. Just remember this. That's enough. In the equation, V is equal to U plus AT. Which quantity is dimensionally incorrect if A is wrongly written as A square? Which quantity is dimensionally incorrect if A is written as A square? If it A instead of A it is A square, then the dimension changes. The equation itself will change. Time and acceleration, no. Velocity is incorrect. See, if A is replaced by A square, then the dimension changes. And if the dimension is changing, then that dimension should be equal to V and U, velocity. So answer to this question is option A. Dimensional formula of coefficient of viscosity. So viscous force Fv is written by eta 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 A dV by dz. So coefficient of viscosity is Fv, viscous force, into dz upon A dV. Force per unit area is force per unit area, dV by dz, lt raised to minus 1 L, ml, this goes up and it becomes plus 1. So you got this a minus 2 plus 1 minus 1. Answer to this question is option A. The pressure of a gas is given the dimensions of R. So R will be PV upon NT. Pressure, dimensional formula of pressure is ml raised to minus 1. Just now we did it. ml raised to minus 1, T raised to minus 2. Volume is L cube divided by mole, and temperature is Kelvin. So ml square T raised to minus 2 per Kelvin per mole. ml square T raised to minus 2. Here it should also be mole in. So we can write option number A. Yeah, everywhere you have to mention the amount of substance. The dimension of magnetic flux. Flux is B dot A. B dot A, and B is magnetic field, intensity of magnetic field, which is given by F by QV. F ml raised to minus 2. Area, A is area, L square. Q is charge. Q is equal to IT, that is 80 into LT raised to minus 1. So L square, sorry, L gets cancelled, L square remains. This T and T is cancelled. M L square T raised to minus 2, A raised to minus 1. Answer to this question is answer A. Which of the following is a derived quantity? Temperature, time, and mass. These are fundamental quantities. Volume is a derived quantity. Derived. Rest all fundamental. So answer to this question is C. If energy, velocity, and mass are taken as fundamental, what is the pressure of what is the dimension of pressure? So we have to find the dimensions of pressure in terms of E, V, and M. So again you have to solve X, Y, Z, and the dimension of pressure is ml raised to minus 1, T raised to minus 2. Energy ml square T raised to minus 2 raised to X. Velocity LT raised to minus Y. M raised to Z. Now we have to open the brackets. We'll get M raised to X plus Z. I am arranging them all in order. L square 2X plus Y and T raised to minus 2X minus Y. Here it is ml raised to minus 1, T raised to minus 2. So comparing LHS and RHS, we get X plus Z is equal to 0. That is X is equal to Z is equal to minus X. Then we have 2X plus Y is equal to minus 1. And we have minus 2X minus Y is equal to minus 2. So that becomes 2X plus Y equal to 2. We have to solve the equations and get the X, Y, Z.